Okay, did everybody get a copy? All right, this is not on the paper, but you have some space like off to the side. If you want to copy this down. This is a quick review from, I don't know, like 6th grade. I don't know when you did this. Long time ago. If you have to factor the number 96, what does factor mean? Remember? You have to like make a factor tree. What does factor mean? What am I finding? I think I know what you mean, but you didn't say it correct, but we have to. 2 times 48? Yeah, I'm not going to do 1 and 96, but I will use 2 and 48. Those are factors. They're numbers that you multiply together to give you 96. Now, when I say factor completely, if either of those factors has factors other than 1, then we need to go further along that tree. So does 2 have another factor other than itself and 1? No, 2 is a prime number. What about 48? Does that have another factor? What makes 48? 12 and 4. I heard different things. There's different answers, right? So we'll just go with one of them, 12 and 4. Now, is 12 a prime number that I can circle and be done, or does 12 have more factors? Okay, so what makes up 12? 3 and 4? So is 3 a prime number? Okay, so I'm going to circle 3. Is 4 a prime number? Or does 4 have factors? 2 and 2? Yeah. And I know 2 is a prime number already. I circled that one earlier. And then here's another 4. So 2 and 2. So once I've circled the end of my factor tree, I found all the factors for 96. So I'm going to rewrite 96 in factored form. I'm not going to write, I'm going to write it right now, but I'm not going to write 2 times 3 times 2 times 2 times 2 times 2. I mean, that's what I'm going to say, but there's no reason to write 2 times 2 times 2 times 2 times 2. How do I write it instead? Three times what? Be brave, take a risk. 2 to the 5th. Yes. And I just put 2 to the 5th first just because I put them in numerical order, but it doesn't really matter what comes first. That would be 96 factored completely. So if I multiplied 2 to the 5th times 3, I would get 97. We are doing this kind of thing today, but we're not using numbers like 96. We're going to use stuff like x squared minus 3x minus 4. And we have to find what you multiply together to give you that product. Same thing. And sometimes we will find 2 things that multiply together, but some of them can be broken down further. Whoops. I don't know if you're laughing, I didn't see what it was. Okay, so we're going to do that today, but with polynomials. And you should have done this in Algebra 1. So this should be somewhat reviewed, but you probably don't remember a lot of it because of when you do it in geometry, you probably don't do that much of it. You kind of forget over a year of not using it. So this is a factoring flow chart. And when we go to do our assignment, if you forget what to do, you want to go to this flow chart. And I highlighted GCF. GCF stands for greatest common factor. I'll write that. Actually, I think it's on there. Yeah, it is on there underneath. It doesn't say it on my copy, but it says it on your copy that GCF is the greatest common factor. Do you see where it says it? Do you see where it says it, you guys? So the GCF is the greatest common factor. So you always want to look for a greatest common factor first. After you do the greatest common factor, then we split into 3 different categories. If there's 2 terms, if there's 3 terms, or if there's 4 terms. If there's 2 terms, you're going to do something that we're going to learn today called difference of squares. If there's 3 terms, you're going to do something we'll learn on Monday called guess and check, but it's the FOIL method backwards. And if there's 4 terms, you'll do something called factor by grouping, which we're going to do today. So we're going to learn the 2 terms and the 4 terms today. And then after that, we go to this bottom that says check all binomials for difference of squares. So the first thing we're going to do is learn the individual things, and then we'll see how we put it all together in one term. So the first category, example 1, we're going to factor out the greatest common factor. And you did this, you multiplied yesterday by using the distributive property. You did that on your assignment. Remember, we multiplied the distributive property. Now we're going to undistribute something. So when you distribute, what operation are you doing? I've already said it. When you distribute, you are doing what operation? Multiplying. So if we undistribute, what's the opposite? Dividing. So you look at 14a and you look at 7. There's 2 terms. Look at both terms. What are they both divisible by? 7? 7? So I'm going to divide both of them by 7. But the 7 does not disappear. It undistributes. It goes in front of a parenthesis. And what we divide out and are left with goes inside the parentheses. So 14a divided by 7 is 2a. And then minus 7 divided by 7 is minus 1. There are 2 ways that you know you did it right. The first way that you know that you did it right is no other greatest common factor in the parentheses cell. So when I look in the parentheses, 2a and 1 are not divisible by any integer anymore. And then the second way is if I distribute it back, if it's the same as the original, then I've done it right. If I just use my distributive property and it equals the original question, then I've done it right. Would that work here? 7 times 2a is 14a. 7 times minus 1 is minus 7. So I know I've done it right. Yay, I have the answer. Woo-hoo. Okay. So the next question. We're looking for a greatest common factor. We're looking for what 108 x to the 5th minus 72 x to the 3rd has in common. I would look at the numbers first, and then we'll look at the variables. Just look at 108 and 72. What are 108 and 72 both divisible by? What'd you say? 9. What'd you say? 36. Anybody else? 12. Anybody else? 2. All of the answers are right, except for we're looking for the greatest common factor. So what's the biggest number that divides out of 108 and 72? 36. 36. So I'm going to divide out the 36 in a moment, but I'm going to also look at the variables. How many variables, how many x's do they both have in common? Do they both have at least 1 x? Do they have at least 2 x's? Do they have at least 3 x's? Do they both have 4 x's? No. So the greatest amount is 3 x's. X to the 3rd. So I'm going to undistribute 36 x to the 3rd. And I'm going to put it outside the parenthesis. And this is where I told you might need your calculator. What is 108 divided by 36? 3. And then we also have to divide x to the 5th by x to the 3rd. So if I have 3 x's that I'm dividing out, how many x's are left over? X to the 2nd. Minus 72 divided by 36 is 2. And when I have 3 x's on top and 3 x's on the bottom, how many are left over? None. So just 2. We're using division. Now, does 3x squared and 2 have anything in common still? No. So I picked the greatest common factor. And if I multiplied it back in, like if I took x to the third times x to the second, would that give me x to the fifth? So if I multiply it back in, does it work? That's how we know we're correct. Okay? One more. Greatest common factor. Take a moment. I'm not going to say it out loud. You're not going to say it out loud. Figure out what you think the greatest common factor is, and you're going to have to like write it down because I can't read your mind. If you feel confident, go ahead and divide it out. To be all 3 terms, not just 2 terms. Okay, what'd you guys get? I was walking around. You all did well. What'd you get? Come on. 2a. So I'm going to take out that 2a by division, and I'm going to have left over how many a's? A squared. Here I've got 12 divided by 2, so I'll have a 6. And then I divide out one of those a's. What do I have left over with the variables? An a and a b. Minus. I'm taking 14 divided by 2, so that's 7. And I'm dividing the a by the a, so I have no a's left over. So that would be it. Okay. And then Chattel asked a really good question. I want to go over what she had asked about. She said, well, these still have stuff in common. So do I take the a out? And the answer is no, because it would have to be in all 3 terms. And that one doesn't have any a's. Okay? All right, so that is greatest common factor. The next is called factor by grouping. And how many terms are we factoring here? It says on the side of your paper. So anytime you're factoring 4 terms, this is the method we're going to approach it with. Factor by grouping. Factor by grouping. You're going to group certain terms together. You're going to group certain terms and factor those. For now, we're going to group the first 2 and the last 2, and we're going to leave a plus sign in the middle. Eventually, it could be different, but for now, first 2 terms, last 2 terms, leave a plus sign in the middle. And then we're only looking at the first parenthesis for a moment, and in the first parenthesis, how could we factor that? Is there a GCF in the first parenthesis? So let's factor out the GCF of the first parenthesis. Oh my gosh, I meant to do something else first. We'll pause in a second and go and do the other thing. But what comes out of 3xy and 15x? 3 and x. So I'm going to put that 3x. And by the way, I am using 2 colors on purpose, so if you wanted to use 2 colors on purpose, this is where I'm switching the color. If you feel like 2 colors helps you sometimes, this would be a good example to have 2 colors. So after I take out 3x, I have a y minus 5 left over. Now I'm going to bring down that plus sign. And I'm going to see what I can factor out of the second parenthesis. 2y minus 10. What comes out? 2. So I have a plus 2. And then I'm going to change my color for what's left over. Y minus 5. Now what I have are two wonderful, beautiful looking terms that have something in common. What do the two things I just underlined in purple have in common? Sure. They both have a y minus 5. That is a greatest common factor. So I'm going to undistribute y minus 5. I'm going to divide out the y minus 5 now. So that's going to go, remember when we distribute it out, undistribute it, it goes in front of a parenthesis. And when I divide that out, what's left over in my first term? 3x. And my second term, plus 2. We just did FOIL backwards. You would know it's right if you FOIL it back together. If I multiply y times 3x, do I get 3xy? If I multiply my outer, 2y, or 2 times y, and I get a plus 2y, it's not in the same order, but if I do my inner, negative 15x, and I do my last, minus 10, it works. That is called factor by grouping. So here's another example, factor by grouping. Our first job is to group it somehow. And we're doing 2 and 2, but there has to be a plus sign in between. So when you do draw those parentheses, make the negative 12 inside the parentheses. So you're kind of making that minus sign into a plus negative 12. And I'm going to factor out my greatest common factor of the first term, or first parenthesis, first group. So I'm looking at 8 and 2. Both 8 and 2 have 2 that will divide out. And I'm looking at a to the third and a to the second. How many a's do they have in common? A squared, right? So we'll take out 2a squared. So I have 2a squared, and then what's left over? We have 4 and an a minus 2a squared divided by 2a squared is 1. Now the next parenthesis, what GCF, what greatest common factor, could I take out? 3? Okay, I'm going to take out 3. If you are using a pen, do not do it, because it's going to be wrong. But I'm going to show you why it's going to be wrong, okay? And then I can erase. So I'm going to take out a 3. And when I take out that 3, what's negative 12a divided by 3? Negative 4a. And what's plus 3 divided by 3? 3 divided by 3. 1. Do you see that these parentheses are not exactly the same? They have the same numbers, but they're different signs. So at this point, I could not GCF those out. They have to be the same. What should I have taken out of that second parenthesis? Not 3, but what? I should take out a negative 3. So I made a mistake, I see my mistake, and now I'm going to fix it. That might happen to you. You might have to go back and fix something. So I'm going to take out a negative 3, and when I take out the negative 3, and I have negative 12a divided by negative 3, that becomes positive 4a. And then positive 3 divided by negative 3 is minus 1. And now my parentheses are exactly the same. So this is one term that I'm dividing by 4a minus 1. And this term I'm dividing by 4a minus 1. So I divide it out. It goes in front, 4a minus 1. And those cancel. I'm dividing them out. What's left over is 2a squared minus 3. Yes.
When you first started dividing out, you always do the opposite sign because you go on But as you talk to me, I like to code, and it's nothing.
I don't know what you mean by
Like, when the actual original equation.
yeah.
Oh, like minus or that.
No. No, I think that's, it happens sometimes, but no. Okay. All right, so that's it for that one? We're on the back right now? Yeah, we're on the back? Yeah.
Will questions ask us to solve a certain way, like grouping, or do you pick your favorite?
Grouping is for 4 terms.
Okay, so it depends.
So it depends on how many terms you have. The GCF, the first thing we did, is for all terms. You always check that. And then if it has 4 terms, we do grouping. If it has 2 terms, see this one's for 2 terms, we do this next one. And you had this in your assignment. In fact, it's called factoring by difference of squares. It's called difference of squares. Okay? Difference of squares. To do difference of squares, I have an example over here. We've got subtracting a squared minus b squared, and it is factored as a plus b, a minus b. On your assignment, I gave you 2 binomials. One was plus, one was minus. They had the same numbers. Do you remember doing those? And what happened when I FOILed those? The middle term canceled out. That's why we only have 2 terms. So that's what we're doing here. So when I look at the first one, 16x squared minus 9, I want to make sure that this is a difference of squares. Is 16 a perfect square? What times what is 16? 4. And what about x squared? X times x. So 4x times 4x is 16x squared. And then the last term is 9, and 9 is a perfect square also. And it is subtracting 9. So what do I multiply together to give me minus 9? A negative 3 and a positive 3, and it does not matter which one you write first. You write the positive first or the negative first. And if you're not sure if you did it right, you can FOIL it back together. First is 16x squared. Outer is plus 12x. Inner is minus 12x. They cancel out. Last is minus 9. So that's difference of squares. How about B? What multiplies together to give us 81? 9 and 9. What multiplies together to give us minus 25? X squared. Positive and minus 5x. And if you check like the outer and the inner, do they cancel out? Minus 45x plus 45x. How about C? Is it a difference of squares? What multiplies together to give us 2 or 4a squared? 2a times 2a. What multiplies together to give us a minus 1? Negative 1 and positive 1. How about D? What multiplies together to give us 4x squared? 2x and 2x. What multiplies together to give us plus 9? Positive 3, positive 3. Does it work? That one looks different than all the others. How's that one different than the first 3 I just did? Because these are both positive. Let me just check and make sure it works. So that's 4x squared. Outer is plus 6x. Inner is plus 6x. And last is plus 9. Does that equal 4x squared plus 9? Why not? There should be a negative in there somewhere. So should I make this like minus 3 minus 3? No? Why? What happens if I make it minus 3 minus 3? happens if I make it minus 3, minus 3? What am I stuck with now? Do I have them canceling out in the middle? So how's this one different than all the others?
You could have two numbers, 1 and 9.
Okay. I'll just rewrite that one. 2x with a 1 and 2x with a 9, but like, which is positive, which is negative? Both positive? Okay. So then that would give me 4x squared. My outer would be plus 18x. My inner would be plus 2x. And my last would be plus 9. Does that get me anywhere? What's the title of the factoring that we're doing right now? What's it called? Difference of squares. Is this a difference? What's difference mean? Is this subtraction? You can't factor it by difference of squares. It's not subtraction. We can't do this one. This one is a number that is not factorable. What is it called if it's only factorable by itself in 1? What's it called if it's not factorable? I've said it there. Prime. This is prime. Do not erase. If you wrote stuff down, cross it out so you know that that was wrong, and it is prime. Because it had to be a difference of squares, not a sum of squares. And you saw why the sum didn't work. So that's why you tricked this. All right, the last section is called factor it completely. That would be like how we had 96 and we did the first factors, but then they kept going. So factor it completely means they might keep going. So the first one, this is where we would use the factor flow chart. So the very first step in that factor flow chart on the front says to do what? If you're not sure, flip it over. What's the first step say to do? 3 letters. GCF. Isn't it true? GCF. Is there a greatest common factor? Timothy, is there a GCF? What is it? Okay, so we factor out that 10. It goes out front. We have left over x squared minus y squared. After you do your GCF, there was an arrow. There's actually 3 arrows on that factor flow chart. You have to know how many terms are left over in the parenthesis. I put them in black. How many terms do we have left over? 2. So we look at the 2 terms. And what is our way of factoring for 2 terms? Difference of squares. Do we have a difference of squares? So you bring down your 10. You'll have your 2 parentheses. What multiplies together to give you x squared? X and x. What multiplies together to give you negative y squared? Plus y and minus y. If the exponent is 1 on your variable, if the exponent is 1, then you know that you're done factoring. If it's something other than 1, you might not be done factoring. I'll show you an example of something other than 1. So I'm going to skip ahead to that bottom section, to number 2 in the bottom section. Skip ahead to number 2 in the bottom section. Lots of people copy that down. So I'm looking at number 2 on that bottom section. What's our very first step of factoring? GCF. Right? Okay. Is there a greatest common factor? Other than 1. But everything's divisible by 1. So other than 1, there is not. So you don't just stop. You just keep going. How many terms do we have? 2. So if it's 2, then what kind of factoring is it? Difference of squares. Is this a difference of squares? What do you multiply by itself to give you x to the fourth. X to the second. Now, it is a difference, so we will have a positive and a negative. What do you multiply by itself to give you y to the fourth? Y second. You see how both of these parentheses do not have x to the first or y to the first. They have something other than the first. So you have to see if either of these parentheses can factor further. So I'm looking at the first parenthesis. How many terms is x squared plus y squared? 2. And if it's 2 terms, we look for difference of squares. Is there a difference of squares right there? No. So can I factor this one? You cannot. Bring it down. The second parenthesis, 2 terms. Is there a difference of squares? Yes. It's subtraction, and they're perfect squares. So I will have x times x, I'll have a plus and a minus, and I'll have y times y. And when I do that, my blue ones now are to the first power, so I know they are done. So that was kind of like that 96 at the beginning where we would keep factoring further. This video will be posted if you need to go back and watch it. And I guarantee there are a million, maybe not million, but there are a million videos out there about factoring. If you don't like the way I described it, go watch somebody else. But factoring is something that is going to occur the rest of Algebra 2 and the rest of your next year math. Whatever you take next year, you have to know how to factor. So this would be an assignment you do not blow off. This would be a very important assignment. On Monday, you have an extra XH period. Did you know that on Monday? So on Monday, the seniors have a meeting, and it's in the morning, so they're going to give us like a study hall in the morning, kind of like an XH, and then your bells are shortened throughout the day. Your first period teacher will have a schedule. I have one somewhere, but you'll have a study hall in the morning. What's your phone cord? You'll have a study hall in the morning, so if you get stuck on any of these, you can come see me then. Do not decide to start it during that XH in the morning, because you can see it's kind of long. But do what you can do and then come ask me questions about the ones you don't understand. Because this stuff is really, 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 really important.